Hello, and welcome back to Learning with Lee. In today's episode, we are going to begin to look at C-style strings. And the main reason we're going to be looking at C-style strings rather than just going forward with C++ style strings is that a lot of what is in C++ is based upon C, and it's designed to fix certain problems that existed with C. So without understanding some of the limitations of C-style strings, we're not going to be able to fully appreciate why, for example, over in here we have things such as this name, which is a string that we're passing around, and why that ends up being a heck of a lot cleaner than what C would require us to do. And some of it's also for why I've put off this topic, even though many people tend to cover strings and input and output a lot earlier, is that strings, at least in C++ and in most other modern languages, are based around object-oriented programming. So without understanding how that works, and to a lesser extent understanding how things such as templates, exceptions, and polymorphism work, you're going to end up struggling to get a good grasp of how strings end up actually being implemented. So, for C strings, the major thing about them is that they are just character pointers or character arrays. And earlier on, we've for the most part gone over what the difference between a pointer and an array is. Just as a brief reminder, a pointer is a reference to a specific spawn memory. It can be changed to be into a different spawn memory, which is one of the key differences. An array basically points to a certain spot of memory. And the other thing is that that spawn memory for an array is constant. So if I basically say that I have an array of some length, then that's never going to change. Whereas with a pointer, I can end up mallocing or reallocating or doing different things in order to basically get new lengths of information for a specific string. However, that happens to be stuff we've gone over in the past for the most part. If you need to, you can go back and rewatch our episode on pointers as well as our episodes on arrays. So, for this, there's a few different ways that you can end up actually initializing or declaring an array or a pointer like this without having to actually specify the size that you want. So, as you'll know in here, none of these I end up never mallocing. I never end up either assigning any values within any of these in here, like I can do down here. So I'm not specifying a size, nothing else like that. I'm just saying, okay, give me a pointer to this string, or effectively in this case here, this array is acting the same as this pointer. This pointer, if it weren't const, could be reassigned, but for now that happens to be a compile time protection against that. So I can end up doing this, and the important thing is that for a string or a set of characters, you use quotation marks like this, the double quotes, and then you use an apostrophe or single quotation mark to represent a character. So basically in this case here we have a space. Because when it's a character, it's important to note that even this little space in here is a specific single character. Just as this is, and really this entire file could be stored as a string or collection of characters. So these are the different ways in which you can do it without having to specify a size in here. I mean, technically if I wanted to, I could just do this and just have some character here. I won't want to output it because I have no idea what's at that spot in memory, but that happens to be another thing that you could do in terms of just initializing a pointer and just treating it the same as any other pointer. But for now, these are all different things you can do. An important thing to note, this notation down here where you use the braces, followed by basically listing off each of the elements that you want within your array. So basically you go, okay, I want an S, and then you have to use a comma, and then whatever your next element is, and so on and so forth. And that's going to basically build up an array similar to this. It just is this general style of array also works for, in case I were to make this an integer, I could actually then do this same sort of thing, and then I could also just replace this, say, with like 50, and go down through the line like that, and have a whole bunch of elements in there. So both of those different notations work fine for this style of initialization without caring about how large it is, but does have some limitations to it. So right now, if I just run this, you'll see that for now, and we can ignore some of these later ones down here, these first three here, you can see how they end up being output correctly in terms of saying it's a C-style string, also a C-style string, and so is this, which is what these three end up representing. One thing that you'll note that's a bit odd is this character here. namely because of the fact that it has two characters, first the backslash, then the 0, within what is supposed to be only a single character. You might be wondering, well, why can't I do this in these other ones? And that's because this happens to be a special situation. This backslash here is what's known as an escape character. And basically it means that whatever character follows that backslash is going to have different meaning than usual. So basically you're compounding the two to generate a single character out that otherwise wouldn't have a representation on your keyboard. And that's the major thing, is that this one here, what it ends up specifying is that this is the end of this string. Normally this gets automatically appended for us by this here as well as by this here, and it's invisible to us. And that's one of the biggest problems about higher level strings that we'll get into, is that this sort of end of string character happens to not be visible to you. And we'll get into what all the different escape characters are in the next episode, as they are fairly important and you'll end up seeing and using a fair number of them. And even if you don't end up using them, you'll end up using things that are effectively similar, because in things such as cout, things such as endl happens to be very similar to some of the different escape characters that there are out there. So it's important to understand what they are, and basically that most languages are going to have maybe not the exact same ones as C does, but they'll have different representations of a lot of those same characters. So this is something that you have to be very aware of when you're dealing with strings. Every single string needs to be terminated by this. If I do not have this on here, and this is going to lead to some potentially serious problems for our program, and then I build this and I run it, you're going to see that right now it is fine. However, here's the thing. Basically what ends up happening here is that it starts outputting this string, keeps outputting it, and the thing is, it doesn't know where to stop. You can think that it's going to stop, okay, well, it's going to stop at the end of the array, but the thing is that in traditional C-style arrays, you don't in general know how large they are. So for this, let's actually demonstrate it with something a bit more obvious and that could give us a problem down here. So for this, we have this array of max string length. We don't know what's in there when we allocate it, we have to assign it manually. And this is a more traditional way of doing arrays, in which you then basically assign each element individually. You might initialize it using something like this in order to basically pop in all of the original values. But this happens to be a way of doing it. And we can just comment out this line here. And what you're going to see is that it's going to go for at least, well, it's going to go until it encounters this character, until it reaches this max string length, in which case it might end up giving us an error, or in case C++ is smarter in terms of how it's compiled than C is, it might detect that length for us. But in general, it's going to be stupid, and it's going to just keep going, and you can see how it generates this little thing here specifying it doesn't know what a certain character is. Note how up here, we're missing this character here. So it only gave us one of the two zeros, and then it gave us this period. So what that ends up meaning is that it ended up executing some additional operations down here that basically caused us to go in memory, wipe out one of these zeros, shift this one over to that zero, and then also try to print out this. And not having this end of string character in a string is a very common problem for new programmers and people who are still getting comfortable with how traditional character strings work, in terms of that can lead to different, not just output errors, but it can lead to things being run incorrectly. It can lead to your program crashing in case you try to access memory that doesn't belong to you. It can lead to a fair number of different issues. So that is something to be very aware of, very cautious of, and make certain that any time in which you're manipulating, copying, or doing anything else with strings, that you account for this character here. And when we get into how strings are copied from one to another, and we're just going to ignore that for now, you have to remember to include that in the length of string you want to copy. If you end up going, well, let's just say that I have something, and we can just call this one for now, const char, and we'll just call it Lee, and have it equal to Lee. So let's say that I want to copy this string into, const char pointer, and I want to copy this into another string. Well, you might think, okay, well, I could just copy these three characters and that'll be fine. And depending on how you're doing it, in case, for example, say I was inserting this into this string here, right between is in this space, then I would only want to probably insert these 3 characters, because in case I insert those 3 characters and the end of string character, all of this is going to be effectively cut off from that string, yet it'll still exist in memory. So that happens to be a potential problem. However, in case, for example, I'm appending this onto the end of this string here, and I'm removing this one here because I need to be able to actually access the word Lee, then what I'm going to have to do is I'm actually have to remember that there's actually a hidden 4th character, and that hidden 4th character is this end of string character. And that's going to be something that's basically represented by this second quotation mark over here, that is hidden away from us, and it's going to be very important to maintain knowledge of that and copying it around. So the next thing we're going to take a look at is, can we actually modify these strings in here? I've left this commented out for now, so let's just uncomment it and do a quick little basic test. And as you'll see, it's going to first give us errors, and that's because I defined these as consts. And as it's saying, fairly obviously, cannot assign to a variable this const. So it's basically saying, I've set this to be this string, it cannot be modified, make certain at compile time that nothing tries to modify it. So let's just say I get rid of that though. Let's say I'm a bit lazy, decide, okay, I don't need to worry about saying these are consts, nobody's going to try to use them in a non-const manner. Then I can build this, doesn't give me any errors, and run it, and you notice how now it crashes as soon as I get in here and try to start modifying them. So let's see now, since string A obviously could not be modified, let's see now if string B can be modified. It's going to complain about that one, so let's just comment that out. And now let's try string B. So we can run this, and it's also, once again, going to crash. So we can just comment this line out. And then string C. Can we modify it? We can actually modify, in this weird situation, this string here. So that's an important thing to note. If you initialize it using this style versus this style, you can actually modify this version, but if you try to modify this version, it will crash. So that's an important thing to keep in mind. And in general, you want to use the const keyword to prevent people from doing anything like this, because it will end up limiting you at compile time rather than at runtime. And that's in general a better situation than having your program crash because somebody did something that they weren't supposed to do. So now down here, and let's just rerun this to reset sort of our set of strings down here, we're going to take a look now in case we define what the length of a string is without actually doing anything else for it. Because you can do this sort of string here in which you just treat it the same as any other array in which you go, I want some array of some size. In case you remember when we were dealing with linked lists, how I would pass in that case there was 100,000. To basically do that, character arrays treat the exact same way as those in terms of pass in your size, and then you can modify each of the elements individually. And if I, for whatever reason, want to, I could even do something such as, let's just copy random one down here, and I could then overwrite things I've already written. So I could do something like equals t, or anything else, whatever. Or I could do equals space, or anything else. So this happens to be something else that you can do, and it's not going to complain when I do that. It still is going to work. You note that now it's missing the s there. And the important thing to remember is to append on this end of string character. For now, this is a good enough understanding of how this works given what we've already covered in the earlier section up here. Since you can see how that works, let's deal with now dynamic strings, because we've already dealt with how to create basically an array using dynamic memory. We went over all of that during the linked list example earlier on. So we're just mallocing, and technically in here I should actually do max string length times, I want to do size of and character in there. What we're then going to look at in here is that we have this line here. And this is something that I haven't really covered yet in terms of what it is. And memset, similar to malloc, is a standard library function from C. Not from C++, mind you. It still exists in C++ because C++ includes the C standard libraries. However, what it does is it basically goes, I want some pointer to memory I want something to set that memory to. In this case here, I gave it the end of string character. I could frankly just give it something such as 0, or I could give it any character. I could give it a number. But really what we want to do is we want to make certain that in case, for whatever reason, whoever's using this, if they forget to actually put in a character that isn't the end of string character here, that it still is handled for them. So doing this sort of little memset for them takes up additional time in terms of computation, but at the same time it happens to be a lightweight enough operation that it can be worth doing to ensure that your C strings are correct. It's not necessary, but at the same time it does make it a bit easier to avoid messing yourself up. So you create your chunk of memory using malloc. You set it so as that, and the important thing here is that start with your pointer, whatever you want to set it to, and then the length of that pointer. So the amount of memory you want to set to that value. So in this case here, we just set it basically every element in there. And then just to re-emphasize some earlier points here, in that pointers and arrays effectively are similar in this regard. So I can end up doing stuff such as basically go, okay, here's my pointer. I want to offset it by some amount of characters. And I want to dereference it to get some value here. Alternatively, I can do that same exact operation just by using the subscript notation that you use for arrays, even though this just happens to be a character pointer. And both of those are perfectly valid ways of doing it, and you can assign and modify each of those values within CString Dynamic. So it'll end up doing that, and then it outputs it. And also, if we wanted to, we could even do something such as comment out this to see that more than likely this is going to give us some errors due to the fact that we aren't actually outputting all of these into that chunk of memory. So if I run it, you can see how down here now, it has all of these ones here. And quite frankly, it might honestly even go beyond 100 characters. But that's something that, so long as you don't have this end of string character there, it's going to keep doing that anyways. So that happens to be a decent overview of how to actually create and character by character modify a C-style string. And one important thing to note here is that I'm saying C-style string, and that's because, in case I call it like this, C-string, I don't currently have the library involved in it, but C-strings are their own special class that are used by some of the Windows UI libraries, and are things that you'll end up using to draw strings in case you happen to be using C++ for your windowing and for your different drawing stuff in terms of how you're actually displaying stuff to the user. It's an important thing to note that if somebody says a C string, they could either mean that particular class or a C style string. In this case here, I'm talking about C style strings, so strings the same way that they were in C before C++ ever came along. And really, I think that's all that we need to cover for today's episode. In tomorrow's episode, we're going to be getting into the different escape characters, what they do, what they're used for, and some of the nuances with them that vary between things such as Windows and Linux, because unfortunately, there are some differences between how some of these are represented in one operating system versus another. So, thank you very much for watching. Have a wonderful day.